So it's been a few weeks now, and I wanted to give an update on the state of the hardware for the Handheld DMX console. I've been working on a couple different PCB designs, and this is actually the layout of the first version here. We've got a 1599E series case from Hammond with the battery door on it. I've got a divider that I can use to put the battery in like that, and once that goes on, I'm able to get access to the battery through there like that. I've got a 9-volt battery that is going to be used for the main power. Again, this device is going to be powered by both battery and USB. I've got the main board here, which includes the PIC32. I've got the DMX and its isolation circuits, the driver, and then I've got a power supply, and I ended up having to make a second version of the power supply. The first one, I wasn't able to solder some of the parts down. It's just getting too difficult, so I decided to do a second version just to make things a little bit easier. So I've got that sitting here. And then for the actual user interface, I created it as a separate PCB. So this sits in the top box portion, and then the control board would be mounted here in, they call this part the lid, like that. The DMX connector goes right about here. This goes on top. The power connector was, or the power button was going to go about here. Then the USB connector was going to go here. And I'm not going to talk much about those because I've actually completely redone this design. Most of this hardware has actually been changed. In fact, the main thing that stayed the same is the case itself. So this entire user interface is going to be replaced by a membrane keypad with a cutout with for the window for the OLED. And on this one, it's an actual, they're actual tactile buttons down here, and those are again getting replaced by the membrane keypad. This is just a piece of paper I printed out with the pattern on it just to give me an idea of how it might look like. Originally I was going to get a whole graphic overlay to replace this paper and make it look a little nicer, but since I'm doing the membrane keypad, I'm not going to go that direction. And actually, a couple of the other things that have changed are the power circuit and the microcontroller itself. Since working on the first version of the project, I've actually decided to switch to an STM32, and I've got this one on a Nucleo board here on the breadboard. And then here I've got the connector for the push buttons and the OLED display, and then I've got the DMX driver circuit here. And the STM32 gives me a couple of advantages, including a lower power consumption, a smaller cost, and quite frankly, the IDE that I use to program it is running a lot nicer than MPLAB was, and I'm liking that a lot better than the microchip software. Another thing I replaced is the power supply circuit here, and so the power supply circuit has a couple main goals. It needs to be able to switch between a 9-volt battery and the USB, with priority going to the 9-volt battery. So if the with priority going to the USB. So if the USB is connected, the device will be powered by USB. If not, it'll be powered by 9-volt battery. The battery should also have some way of reading the voltage off of it so I can get an idea of the level. That'll go back to the microcontroller. And then I need another way of telling whether the device is powered by battery or by USB. And it should also regulate the whole thing down to 3.3 volts. And I came up with this little circuit here. The main part is the LTC3126. It is a fairly expensive part. It comes in at $11 in one-off quantity, but the solution between this and the version I had in version 1 of the hardware actually ends up costing about the same. They're both about $14 or $15 in one-off quantity, which is a lot, but it's worth it in my case. I've also added in, to replace the power button, this on-off controller. It's a Maxim chip, and its job is very simply, in this case, the white wire here, when I connect this to ground, so in my case I would just have a push button between this and ground. It's got an internal pull-up. When I connect it to ground, it'll either switch the unit on or off, and that's wired into the VCC of this guy. And so even when this isn't regulating the main output, this is still getting power, and that's better detailed in the schematic. And if you look at the data sheet, I'm not going to talk much about that here, but it is a really nice solution. I haven't tested it yet, but it should apparently only be a couple microamps of quiescent current when the system is not running, which will be really nice not to drain the battery too fast. And all in all, it's a pretty elegant solution here. And so right now it's not hooked up to the rest of the system here. I actually just got this circuit and was just doing some testing. But this whole solution here is actually coming in at a slightly better price point. The membrane keypad is going to be more expensive in smaller quantity, talking about $270 to get 10 of them, which is a lot. But compared to the cost of labor of trying to solder on all of the buttons and drill 24 holes, because underneath this, I can just pull this off. I don't really use it for much anymore. If I take this off here, you can see there's all of my push buttons. There's all the holes I drilled. They have to be drilled in the right spot. The push buttons have to be soldered in exactly the right place. And so a membrane keypad's just a more ideal solution for this, because it's a significantly lower labor cost. I don't have to drill all these holes and do all the soldering. Just have one keypad, cut out the slot for the OLED, cut out the slot for the FFC cable to go to the PCB, and boom, that's it. Just stick down the keypad there. So the PCB that is shown here, this is the main control PCB. You can see this is the connector for the FFC from the membrane keypad. I've got the OLED display header here. This is actually upside down. This, although this is considered the top of the board in this case, it is actually the bottom. The OLED display is going to be going on the physically top side, and all of this is going to be going on the bottom, and then this is going to be mounted up near the top of the box. And this PCB, along with a test PCB, this is just a series of buttons designed for testing in replacement of the membrane keypad. These are actually on order now along with all of the parts, and hopefully I'll have both of them within the next few days, and I'll be able to demonstrate the usability of this system, and hopefully I'll have a functioning device that I can actually start programming and start carrying around with me, and hopefully the pandemic ends soon so that I'm able to actually do some testing out in the field. So as you can see, this project is well underway. Hopefully I'll have something more tangible to show for it soon. Thanks for watching.